Okay, let's have, for example, this another problem here. Determine whether the following equations are dimensionally consistent. For example, number 1, we have v equals 80, then 2 v equals m plus 2ax, and 3 we have x equals vt plus 1 half et squared, where x here has dimensions of length, v has dimensions of length over time, a has dimensions length over time squared, m has dimensions of mass, and t has dimensions of time. Okay, sige. Please do it in maybe 2 minutes to 2 minutes siguro. Okay? Sige. Okay, so now that I believe you've solved some of the problems. So okay lang yan if you haven't. Isa-solve ko rin naman yan. So, number 1, v equals 80. I will be using the notation L for length, m for mass, hindi yan meter ha, and t for time. Okay, sige. So this means that we know that the units of v is length per time. So this is L over t. So this means that the acceleration, on the other hand, has units of length over time squared. And then when we multiply it by t, so this is some multiplication by t, just like in usual algebra, units can be manipulated accordingly. So this t here will cancel. And therefore, we get length per time equals a length per time. And therefore, since the two equations are have the same units, we say that this is a dimensionally consistent quantity equation. Okay? Clear ba tayo doon?
Yes, sir.
Okay, so this is dimensionally consistent. The first item is dimensionally consistent. Then, second, we have v equals m plus 2ax. Again, v has units of length per time. Now, note here we have 2 here. The 2 here doesn't mean anything in dimensional analysis. You can ignore it. Just ignore it. If you have constants multiplied to some numbers, just ignore it. They don't mean anything for the context, in the context of dimensional analysis. So it's length per time equals m as units of mass. So units of mass plus 2 is just ignore 2. We have length per time. Length per time squared, sorry, and then length. Okay, questions? But here, obviously, this has units of m, and we have units of L squared over T squared, and we know that you cannot add two quantities of different units. So therefore, this is dimensionally inconsistent. Okay? Questions? May tanong ba?
Wala po.
Walang tanong? Okay. Are there any questions for this particular item? Then part 3 is we have x equals vt plus 1/2 a t squared. So x here has units of what? X here has units of length, diba? Then v has units of length per time. And then t has units of time. And then 1/2 here again, you can ignore it. So just I won't write it anymore. And then a has units of length per time squared. And then t has units of time, but it's squared. Okay, so in that case, that you can again use your ordinary rules in algebra. T will cancel here, and then L over t squared will cancel with this one, and therefore we have L plus again L, and we can add these two units. Therefore, units of length equals units of length, and therefore the third equation is dimensionally consistent. Okay. Are there any questions in this particular item? So therefore, in summary, the first equation is dimensionally consistent, the second one is not, and the third is also dimensionally consistent. Are there any questions in this particular item?
None so far.
Okay.